For today's notes, we're going to talk about the area of a trapezoid. We've seen trapezoids before, and so where we're going to start is looking at the key pieces of a trapezoid. We know that a trapezoid has two bases. The upper base, we're going to call today B1, and the lower base we're going to call B2. We'll see that both of those numbers end up being important in our formula. Next, we also know that trapezoids, along with most of the figures we've seen, have perpendicular heights. So we're going to draw on our perpendicular and call it the height. All of these pieces will incorporate into our area formula to give us that the area of a trapezoid equals 1/2 the product of the height times the sum of the bases. So when we put this together, this gives us the area of the trapezoid is equal to 1/2 base 1 plus base 2 times the height. You'll see base 1 plus base 2 are in parentheses because that's how we add them together and group them with order of operations. So this here is our area formula. Before we move forward, we are going to do one more piece, and that involves a new segment that we will call the median. So for the sake, I'm going to copy our trapezoid and paste it in our next screen. And here is the median. The median is the line segment connecting the midpoints of the non-parallel sides. So our median, we need to draw the midpoints of our non-parallel sides. And then when I take a line segment and connect between those points, that line segment formed is the median of the trapezoid. So what we'll notice here is that the median, it comes out to be parallel to our already parallel bases, and it's going to be halfway across the height of this trapezoid. And so that leads us into our next theorem, that in order to figure out how long this median is, we can determine that the median is equal to the average of the measures of the bases. Well, how do we average something? We add it together and we divide it by 2. So that gives us the median is 1/2 of base 1 plus base 2. So going back up to our example, if I call the upper base 4, the lower base, maybe let's say it has length 10, then the median, we know that it will be 1/2 of 4 plus 10, which gives us half of 14. So it has a length of 7. That's how we determine the number exactly between 4 and 10. So we've seen this before. 1/2 base 1 plus base 2, it should be ringing a bell that in our trapezoid formula, we have also included that same expression. So what we can do as we wrap this up for our new content is we can adjust this formula and we can replace for our area of our trapezoid, 1/2 base 1 plus base 2 is just the length of the median. So that means that the trapezoid formula could also be the median times the height. So this gives us two different formulas using different pieces to find the area of our trapezoid. What you'll find is that we'll usually know base 1 and base 2 more often, but sometimes we do know the median, and it makes our job very easy to find the area. So let's look at a couple of examples. This first one, what do we know? We know that AM is parallel to RP. Those are my bases. We know AR is congruent to MP, which makes this an isosceles trapezoid, and those are 13. We know AM is 15, and RP is 25. So as we go back to our area formula, the area is 1/2 base 1 plus base 2 times the height. So far, we know base 1 and base 2. It's 15 and 25, but we don't know the height. At this point, if we were in class, I would ask you to pause. I would ask you to think, how can we find the height? What do we know? My guess is many of you already know how to do this. So if you do, pause the video, find the height, and then I'm going to continue working this out from here. Hopefully you can get the same value. So remember with the trapezoid, we found that if we drop a height to the base from the corner of where the legs intersect, we form right triangles in a rectangle. We also know that with the rectangle, I know that middle section of the base on the bottom is 15. And then since it's isosceles, I know that the two bottom legs of the right triangles will be the same length. So now, if the whole base RP is 25, the middle section is 15, that leaves me 10 units to split. So that makes the bottom part of this triangle 5 and 5. And hopefully now you're recognizing that we could use Pythagorean theorem to find the height, or we also know that this is a special right triangle, which would make the height come out to be 12, a 5, 12, 13 triangle. So now we can go down back to our area formula. We can plug in our pieces. So that would make base 1 15 plus base 2 of 25 times our height of 12. So now this gives us 1/2 of 40 times 12. Now you have a couple of options. You could multiply the 40 and 12, or sometimes the mental math is easier if we reduce these numbers. The 1/2 only multiplies with one of them. So maybe let's do 1/2 of 40. So that gives us 20 times 12. So 2 times 12 is 24. So that gives us 240 square units. And that is the area of this trapezoid. So that's a nice basic application of how we find a missing piece, we go forward. We're going to look at one more of those, and then we're going to look at more of a challenge problem. For example number 2 here, here's what we know. I have a trapezoid, and they asked me to find the exact area. I know base 1, I don't know the height, and I don't know base 2. So there are multiple pieces that we're missing. There is nothing here that allows us to assume this is isosceles. I know this angle is 45. I cannot assume that the other base angle is 45. So we have to use the information that we know. Well, thus far, I know that I can cut my other height to form another triangle. And I know that these two heights will be the same. And I know the middle section of the bottom base will be 12. Let's go ahead and remind ourselves that we're looking for base 2. We need all those pieces. I don't know that the angle of my base is 45, but I do know it's a right triangle, that I have both sides. You could use Pythagorean theorem, or hopefully we're starting to recognize those triples. That makes this side 8, which would make my other side 8, and that is my height. I now know that my height is 8. So then now, going to my other triangle, because it's a right triangle with one 45-degree angle, it makes it a 45, 45, 90 triangle. So we know that the other leg would be 8, and then the hypotenuse, making the leg of my trapezoid 8 root 2. So now in total, if I go back and sum up all 3 pieces, that makes this bottom base come out to be 26. So now that we have all the pieces, we can find the area. So that makes our area 1/2 of 12 plus 26 times our height of 8. So now I'm going to, let's see here, this gives us 38 times 8. All right, and this time I'm going to multiply 38 times 8, giving me 304. And then now I'll take that number and I'll divide it by 2 to give us a total area of 152 square units. All right, so there's a couple of basic examples. Let's look at one more here before we finish. That is a more complex example. Number 3, they tell us that the sides of a trapezoid are in a ratio of 2, 5, 8, and 5. So they don't tell us how long they are. They tell us the trapezoid's area is 245. They ask us to find the height and the perimeter. So let's go ahead and draw a trapezoid. So now I have to figure out, with ratios, hopefully you are familiar with the fact that we will represent that the ratio has some multiplier that makes them the correct values to make that area 245. We don't know what it is, so we'll call it x. So when we go to figure this out, remember that the bases of a trapezoid have to be different lengths. There's 2 numbers that are the same, 2 numbers that are different. So that makes my base, just lost a trapezoid, so let's go back and redraw that. There we go. Okay, that would make my bases 2x and 8x. That makes the other legs 5x and 5x. So we now know this is an isosceles trapezoid. So then now I know my whole lower base is 8x. So when I think about the area, I know that 245 will have to equal 1/2 of base 1 plus base 2 times the height. I know base 1 and base 2, at least in terms of x, but I don't know the height. So let's see if I could find an expression for the height in terms of x, then I could at least use that in my formula. So here's what we know thus far. The middle portion will be 2x. If the whole length is 8x, that leaves 6 x's to be divided evenly, which would make these pieces each 3x. Hopefully at this point you're now starting to recognize the 3, 4, 5 triangle. Even though there's an x, they all have an x, so that would make my height have an expression of 4x. So now that means 245 is equal to 1/2 of 2x plus 8x times 4x. So let's see here. This gives us 245 times 1/2. 2x plus 8x gives us 10x. So this becomes 245 equals 1/2 of 40, and then x times x becomes x squared. This leaves us with 245 equals 20x squared. Now before we square root anything, let's divide by 20. Now, 245 is not divisible by 20. You can do a decimal, but I would prefer let's work with fractions to get the practice. So this gives us x squared. They're both divisible by 5. And a quick check, 245 divided by 5 is 49. 20 leaves us with 4. Here's why I wanted you to do this. As a reminder, when you square root a fraction, we can individually square root the top and the bottom. This gives us x is equal to square root of 49 is 7, square root of 4 is 2. X is equal to 7/2. If you put that decimal, you should get 3.5, but this is nicer, better number. So lastly, it asks us to find the height and the perimeter. So now we just need to replace x in its spot. So that gives us that the height would be equal to 4 times 7/2. As a reminder with reducing fractions, the 2 can reduce the 4, leaving us with a 2 to multiply with the 7. So that gives us a height of 14 units. And then for the perimeter, you could do this a couple of different ways. You could plug in x on all of the 4 sides. It's going to take a lot of work. Let's add them up with the x's already there. When I add them up, 5x plus 2x plus 5x plus 8x, that all adds up to 20x. That gives us 20 times 7/2. Again, 20 is divisible by 2, so that leaves us with 10 times 7, which gives us a perimeter of 70. And there we have it. We have figured out all the pieces of this trapezoid that we are looking for. At this point, this is all of the new stuff. If you're interested to see one more example, I'm going to work through example 4. Otherwise, your next task is to complete the practice for 10.3 area of trapezoids. I believe there's 5 questions on it. Good luck. All right, example number 4. With example number 4, here's a couple of things that we have going on here. I know a side is 12, and I know both base angles are 60. That means that this is an isosceles trapezoid. So that means that this side is 12, and it also tells us it's congruent to my upper base, that's 12. For my area, I don't know the lower base and I don't know the height. So we need to find base 2, and then we'll need to find the height. The great thing is since it's isosceles, our job is a lot easier because I know that the 2 pieces at the bottom of my right triangles will be the same length. So this is length 12. And then now I don't have information to figure out those lengths except for these 60-degree angles. That makes these 30, 60, 90 triangles. So remember that across from the right angle is the 2x side. So that means across x would be 6, and that goes across from 30, which goes on my lower base. And then that makes the side across from 60, 6√3. So then, since that height is the same at any point in the trapezoid, the other piece would be 6√3, The other side would be 6, and that would still be the same because we know that this is an isosceles trapezoid, and those pieces have to be congruent, and it's a 30, 60, 90 triangle. So now when we add up those pieces, that makes base 2 come out to be 24. So that means that our area is 1/2 of 12 plus 24 times 6 root 3. The one unique piece here is we are now working with the square root, so that gives us 1/2 of 36 times 6 root 3. To make the math easier on myself, I'm going to take 1/2 of 36 first. So that's 18 times 6 root 3. And then 18 times 6 is 108. So this becomes 108 root 3 units squared. And that is our final answer. Remember, with a square root, unless there are other square roots to multiply, it comes along and it joins our numbers. Lastly, it does ask it to the nearest tenth. So let's go ahead and put this in. 108 root 3 is about 187.1. So our answer here, this will slide out of the way, comes out to be approximately 187.1. And that is it for section 10.3.